There is a spelling error. Dev.keras.layers. Just wait a minute. Let me check what the exact. Okay, tf.keras.layers. So, could not interpret optimizer SGD. Okay, so okay, fine. So let's fit our model and update our weight. So for that we'll write model.fit and we'll pass the x text values. These are the data points without the label, and we'll pass the since the labels are not one hot encoded, so we'll use tf dot one hot to encode our values, and we'll pass the y test, and there's another parameter called depth. So here we'll need to pass the number of classes that we have. So we'll write len and we'll pass classes. So that, and also we have to pass epochs. So what epochs is that it will tell us how many times all the data sets would go through the training process. So let's say if we have 100 data points. So if our epoch is 5, so all the 100 data points will pass through the model 5 times. So in total, there would be 500 data points that will be passed through the model and will be trained. So but there is also another thing called batch size. By default, the batch size is 32. Since we are dealing with large data sets, so it will not feed directly all. Let's say our model has 1,000 data points, so it will not directly feed the model the 1,000 data points. So it will divide 1,000 by, let's say, a default value like 32. It will divided by 32, and the number received will be the total amount of data point that will be fed at a particular instant of time. So we'll leave it in, because the default value is 32. So let's train our model. Epoch equal to epochs. So fail to convert elements. Just wait a second, let me check. I think there is some error over here. Let's see. Unknown metric function accuracy. Okay. We'll use MAU. Let's see. Keep in check the spelling. So there was a typing mistake. So since we have only used a single layer, we can see that in the end we have a very bad accuracy. It is 0.04. The accuracy is between 0.1, so it is very poor. And also the loss has become so high that it has gone out of scope. So for that we'll add more layers in the hidden layer, more layers in the hidden layer. So let's write tf.keras dot layers dot. Let's add 62 perceptrons in this layer. We'll pass activation and let's say reload. So Okay, so we can see that there's something happening. So we have to test around different things. So let's say we'll change this activation function in the outermost layer to be let's say sigmoid. So it may affect the final results. Okay, so our accuracy increasing now. So let's see what the final accuracy. Okay, 0.34. So we'll add a new layer. So it is just a method of hit and trial, and you it's a painstaking task. So what you need to do is that you need to try out different combination and play around with it. So once you have a lot of practice, you will get an idea on how to produce the best model. Let's add another layer with 64 perceptrons. We have dot layers dot things. So and we'll write activation to be ready. What relu does is that it caps all the negative values to zero. So if our function sends a value which is smaller than zero, then it will small which is negative, then it will return zero. Otherwise, it would return the same value. We'll write a comma over here. So, so you can see our accuracy is increasing. If we increase our number of epochs, then also our accuracy would increase. So let's write 100. And there are also different optimizers and different loss functions which you can play around with. So see, now the accuracy is getting a lot better. So when we have used 100 epoch, we are getting an accuracy of 0.95, 95% accuracy. So there is also another optimizer called Adam, which is a better version of gradient descent, and it has a greater convergence rate. So let's try Adam also. I had tried different version and found that Adam worked best with 50 epochs. So you will get around 97% accuracy. See, we are going over there. Okay, so 97, we have achieved 97% accuracy on our training set. So it is not necessary that you will get the same accuracy on our testing set. So that was the main reason that we had split our data set so that we can check the actual accuracy on our model that will come across when we deploy our model. So let's evaluate our model. Okay, so for that we'll write model dot evaluate and we'll pass the X test, which are the test data points, and then we'll pass the one hot encoded versions of the labels. TF dot one hot and Y test, and that would be the length of that classes and class. I think there are total 22 or 21 around classes. I'm not checked the exact number, but it is around that only. In class. Okay, so we are getting a good accuracy. We are getting 97% accuracy and the loss is 0.1%. So if you don't want to see all these steps, you can pass up an argument called verbose and pass it as false or zero. You can also write zero instead of false. Okay, so when we'll train our model, we'll not be able to see any mid epoch accuracy. Since I had already trained the model and I had executed this fit function again, so the total number of times are now increased from 50 to 100. So it is not that it is starting from exact 0 point. So you can train our model once again and it will continue from there. It will not start from the beginning. So let's say it might have changed our accuracy. Okay. So there's only a little bit change, not much. So we can continue with this. So what we'll do, we'll try to predict. Okay, we can take an array called ypred, and we'll say model dot predict, and we'll pass the predicting labels, the data points. So it is x test. Okay. So we'll print this. Okay, so you can see that the classes are not there. So what it has done is that each individual element would be of a size of that class. So, see, the first class 0 has this probability, so it is just returning the probabilities for all the classes. So we'll need to use a function to find that index where this probability is maximum. So for that we'll write pf. So we take y predicted equal to pf dot argmax. Argmax is a function which will return the value of the index which has the maximum value. So since this is a 2D array, we'll pass this ypred and put the axis to be 1, so that for all the testing points we'll get the exact index. Ypred. Okay, so you can see we have received these values. So there is, to test how accurate our model is, there is another thing called confusion matrix, which will plot all the testing values and the predicted values, the true values and the predicted values. So for that we'll import a function from scikit-learn. So we write from sklearn dot metrics code classic code confusion matrix. And there is also called classification report that we'll see. It will provide a score of any classification model. Okay, so we can say print confusion confusion matrix. So, and we'll need to pass the y true and y predicted values. So y predicted, and it doesn't require any one hot encoded version, so we can just pass the actual values. And y, okay, y test. Um, Confusion matrix. Okay, so there is a spelling mistake. Okay, so if you get all the maximum values in a diagonal, so then you get to know that you have a good model. And on the right side of the model, these values where you see all the zeros and there are some twos, there are some ones, so these are all the false positives, and on the down over here these are all the false negatives. So I think we'll end our session by saving our model and then loading our model. So we'll write model dot save, and we'll save it with an extension called .h5. So it is a standard extension of TensorFlow. So we'll write model.h5. It will save in the primary directory only.
Sir, it will save in a disk.
Yes, our current library, our current directory. Sorry.
Okay, okay.
So since this collaboratory is in a content folder, see in this content folder, so the model has been saved in this. So you can see model.h5. You can load this model by, let's say we need to load our model by the name model 1. So we'll write pf dot keras dot load model. Maybe it's pf dot keras dot models dot load model, and you need to pass the location of the directory. Since we are in the same directory, we can write model.hy. But you'll need to pass the location. If it is fake, it is stored in another folder or something.
Sir,
Yes,
sir, I am not having a correct idea of HDF5 format.
HDF5. It's .h5.
Sir, HDF5.
HDF5.
Yes, sir, HDF5 format.
Okay, so we can look into that online. I have also no idea about it.
Okay,
HDF HDF5. Okay. Model extension. Okay, so what do you want to know about this? Let's write HDF5 1050. Okay. Just wait a sec. I'll also search. It's. I think it's in another format. It's okay. Garage is one of the most. Also, Garage uses HDFI, which is a hierarchical data structure format. It can represent a nested data structure. Thus, it is very similar to the protocol buffer in this case. So maybe it has a different architecture. You can use this also. Maybe let's try this one also. So dot HDF5. This one. Wait a minute. Let's try to save this in this format. Model dot save. Let's name it as model 2 dot HDF5 if it works. I think what I know is that the only difference between these two would be that this .h5 model can be retrained again. So since I had loaded this model 1, if I write it like this model 1 dot fit, so it will do the further training. Let me try. Express yeah. Will pass depth as the length of that classes list. Oh, we have not. Okay. So let's try with the same thing with this HDFI model. Model. We'll copy this from here. अच्छा तब तक आप ये देख लो ये देखो यही भेजा था ये फर्स्ट फॉलोअप है इसको जेल को the name is model 2 dot HDF5 and we'll rename this as model 2. No file or directory form. Let's see how to load this model. ये है उसका TF garage load HDF5 Let me check. Just wait for a minute. I'll see how to load this HDF5 from my. Okay, so it has created a folder. Let's see what it is. I think it is a more standard one that we'll use while deploying. Okay, so it is a way for storing our data, and so let me close. Let's see what's in this. Assets is empty variables. Save model.pv. Okay, let's see what this pv format is. Dot pv. Model. Okay, so I think it has to do something with the graph model of TensorFlow that had been used before the version 2.0. So since we are using since we are using an eager execution where we are not creating any graph, so I think that's why it's not able to execute it. So let me disable the eager execution. We have got compare. We have got compare
By so far, sir, I have got the basic idea.
Okay, so I think
I
it has to something to do with this eager execution.
Yes, maybe, sir, but I think it is an alternative to save model.
Yes, but you are not able to load this over here. So if it had been an alternative, you would be able to load this. Let's try with.
Exactly.
Okay, so we copy this. Let's model to dot HDF5. HD5F. Maybe I had. Okay, so I had saved it a different name. So we'll first delete it and create again. And check. Empty directories. Let's create with a different name. HDF5. Let's check if it is HDF5 only. Okay, HDF5. Hmm. NumPy is only available and okay. We'll have to run it once again because we have disabled the eager execution. Runtime run all. what's the error over here? TF dot fit. Please provide a model input either a single array or a list of empty pass inputs is equal to. Just let me check. Please provide a model input either a single array or a list of arrays. Pass inputs is equal to sometime. Please start. Yes. ये फार कोई भी मैंने तो नहीं बंद कर रहा था किसी के ये देखो वेंडर पीओसी में भी नहीं है Okay, the error was there because the codes down there were already executed. So we had to disable the kernel environment and then we had to enable it once again. So follow no file or directory found at such. Okay, so now अब इसके साथ हमारा जेन का काम हो गया Okay, with this one we'll do this one. बस तीन में right छोटे छोटे बाकी total 2 is equal to अब आते हैं एरर यार क्या करो यार ये जल्दी हो जाना था ये मैं टक्कर रह गया था models. Okay, so what's the next? Model आज मेरे को जब ने बोला कि जब इसका सेटिंग डालो कॉन्ट्रैक्ट स्ट्रीम को भी टैग कर दो वैसे ही करना पड़ेगा Okay, so let's try to fit this model. वो तो टू में ही डाल दिया मैंने कॉन्ट्रैक्ट स्ट्रीम को अब क्या सेटिंग फॉलो है तो इसमें इसमें अच्छा ये इनको आगे करूँगी नहीं तो गुस्सा हो जाएंगे ये ये फवाद अली हुसैन Okay, so we can fit this model also. So I think there are two different versions, and this H model.h5 is more specific to TensorFlow, while this is not. This model.hdf5 it is a more standard one. So I think that's it. I have told you everything that you need for this ML project. So also TensorFlow is also available for JavaScript. So if you are doing a backend on JavaScript, you can use this model.h5 there also. So okay, if anybody has any doubts, they can just speak up or put them in the chat box. Okay, so we normally talk about this. ठीक है देख लो देखना है तो